There's a few terminology regarding the pressures when we are studying the lung mechanics. Three are basic pressures and the other are derived from these basic pressures. So basic pressures include the intra-alveolar pressure, intrapleural and atmospheric pressure. Here's an illustration before we go into the detail of these pressures. You can see I have made the lungs and the alveoli. Then the blue color cavity is the pleural cavity. The inner wall is the inner pleural membrane, while the outer wall of this cavity is outer pleural membrane, and then there are ribs between. In between the ribs, the with the red color intercostal muscles are formed. So the intra-alveolar pressure is the pressure which is inside the alveoli, and intrapleural is that which is inside the pleural cavity, while atmospheric pressure or the barometric pressure is it is barometric. So barometric pressure is the pressure which is exerted on the chest wall, which is 1 atmospheric pressure. So here in the green color is shows the pressure in the inside the alveoli, and in the purple color I have shown the pressure in the alveolar cavity denoted by PP, and 1 atmospheric pressure is being exerted here, being pointed out with the red arrow. Then there are few terms which are derived from the basic pressures. These are the derived pressure. The transmural pressure, it is derived from the basic pressures. Transmural pressure is basically the pressure across the wall of any cavity, which determines will it inflate or deflate. For example, a cavity of inside a balloon, the size or the volume of this cavity inside the balloon, or the inflation or the deflation of the balloon basically depends on the pressure which is across the balloon material. So the pressure difference, if the pressure inside the balloon is more than the pressure which is being exerted on the surface of the balloon is greater, then it will inflate. If this pressure is less and outside pressure is more, the balloon will deflate. So this is transmural pressure is basically the pressure difference between the pressure inside and outside of that cavity. Regarding lungs, we have two cavities. There is an alveolar cavity, and then there is pleural cavity. And now alveolar cavity, basically alveolar cavity, the wall of alveolar cavity is made of its own epithelium, the alveolar structure, and the internal pleural membrane is very closely, it has a very intimate relation with the alveolar wall. So alveolar cavity is basically formed by these two structures. So the pressure difference across this wall is the difference inside the alveolar cavity and the difference outside the alveolar cavity, that is inside the pleural cavity. So the difference between the intra-alveolar and the intrapleural cavity or the intrapleural pressure is called the pressure difference across the alveolar cavity wall. So this pressure difference is called as transpulmonary pressure. It is being denoted by Tp is equal to Pa, pressure in the alveolar cavity, minus pressure in the intrapleural pressure. Here we can see this one in the brown color is the pulmonary pressure between across the alveolar wall. This wall is made of the alveolar lining and also the internal pleural membrane. Then there is pleural cavity and the pressure across it. There is a pleural cavity. It is from the inside it is it has the internal pleural membrane and the alveolar wall, while on the outside there is the outer pleural membrane and the which has a very intimate relationship with the chest cavity. So the pressure across this chest wall and the outer pleural membrane, it determines basically the inflation or deflation of this pleural cavity. Most of the time the pressure inside the pleural cavity is in the negative, which is mostly minus in the normal condition when the lung is having the residual volume. We will discuss it in the detail. It is -5 units. So the pressure across this wall is called the transthoracic pressure. It is a pressure difference between the pressure inside the pleural cavity, which is the intrapleural pressure, and the pressure outside the pleural cavity. And the pressure being exerted on the chest wall, which is atmospheric pressure, or the atmospheric pressure or the barometric pressure. So it is being denoted by, here is a diagram for it. Here you can say in the purple, transthoracic pressure is equal to intrapleural and pleural pressure minus barometric pressure. Then there comes the transrespiratory pressure. It is basically the pressure which is across both of these walls. Means it is the pressure difference between the intra-alveolar pressure and the atmospheric pressure. Here you can see, as in the orange color, it is across both of these walls. So basically there are three basic pressures, which are intra-alveolar, intrapulmonary, and barometric pressure or the atmospheric pressure. While there are three derived pressure, which are transmural pressures, which are three in numbers: transpulmonary, transthoracic, and transrespiratory. So how can we measure these pressures? If we measure the basic pressure, we can measure definitely the derived pressures. So the pressure inside the alveolar cavity is measured with the help of manometer, which is inserted in the airways, while the pressure inside the pleural cavity is measured by inserting the manometer with the help of catheter inside the esophagus, and in the lower when it reaches the lower third of the esophagus, it has a balloon attached with it, which inflates, and then it exerts pressure on the dorsal mediastinum, and the pressure of that it is of that muscle, dorsal mediastinum, is basically determined by the pleural cavity pressure. So in this way we can measure the pressure of inside the pleural cavity or the intrapleural pressure.